Good morning, everyone. My name is Opozi, a student from University Malaya, Bachelor of Science with Education, major in Chemistry, and I would like to teach the topic of carbon compounds, which is the chapter 2 of the Form 5 syllabus. In this video, I would like to mention on the alkenes. Okay, so we'll look at the chemical properties of alkenes. So the learning outcome of this pre-recorded video is a student is able to describe the chemical properties of alkenes. Referring to this slide, reactivity of alkenes. Alkenes are chemically more reactive than alkanes. Why? Okay. This is due to the presence of the carbon-carbon double bond in the alkene. Remember the fact of alkanes and alkenes. They are the only two hydrocarbon. Alkenes, they are saturated, while alkenes, they are unsaturated. And remember that what is meant by saturated and unsaturated hydrocarbon? Saturated hydrocarbon is the carbon-carbon atom is linked with a covalent single bond. However, for unsaturated hydrocarbons, the carbon-carbon atom is linked with a double bond. Okay, in alkenes, you can have one or more double bonds. So based on the molecule. Okay, there are three reactions which can show the chemical properties of alkenes. First is combustion. Then alkenes also undergo addition reaction. And the last one is polymerization. Okay, the first reaction is the combustion of alkenes. Alkenes burn completely in excess oxygen to form carbon dioxide and water. So look at the chemical equation. The first chemical equation, okay, we have ethene burning with excess oxygen and you obtain carbon dioxide and water. So if the question asks you to write a balanced chemical equation for the combustion of ethene, so you need to know that you have to balance the coefficient. Okay, so take note that you need to give prioritize for the limiting reagent. The limiting reagent in this chemical equation is ethene. Okay, so we'll balance the number of atoms of carbon first. So on the left hand side, we have two carbon atoms. So CO2, right, at the right hand side, you need to get two carbon. So you multiply the 2 with the CO2. Then move to the hydrogen. There are 4 hydrogen atom on the reactant side. So you need to also have 4 hydrogen atoms on the product side. So H2O already have 2 H atoms, so just multiply with the 2 in front. So you also get 4 on the product side. So now you will only consider the coefficient number for the oxygen atom. Okay, so you have 2 times 2, 4 from the carbon dioxide and 2 times 1 from the water. So total of number of oxygen atoms is from on the right hand side is 6. So you need to have 6, also have 6 oxygen on the left hand side. So we already have 2 because oxygen molecule O2, right? So just times the 3 on the left hand side. So we also get 6. And then now it's only the equation is balanced. So the next example is the combustion of propene, okay, C3H6. So applying the same steps, prioritize the C3H6 first. Okay, 3 carbon on the left, so CO2 times with 3. Then 6 hydrogen on the left. Okay, you already have 2 at the right hand side, so also times with 3. So now we only consider the coefficient for the oxygen Okay, so 3 times 2, 6, plus 3 times 1, 9. You need to have 9 oxygen, but you already have 2 on the left hand side. So how you get 9, the whole number? Okay, so in this case, fractions can be accepted, so you can write 9 over 2. Okay, 9 over 2 times 2, you will get 9. So if you don't want to leave your uh, the chemical equation in fraction form, you can times with the denominator. So it will become a whole number. So you have 2C3H6 plus 9O2. Then you obtain 6CO2 plus 6H2O. As you can see, there's a picture on the last line. It's how you conduct an experiment of the combustion of alkenes. So you note that alkenes will burn with a yellow flame. So the flame will, sometimes you will noted that the flame will be will have black color. So this one is we call sootiness. Why? Because it contains carbon. You are burning a carbon compound. Okay. The second point here, the flame is more sootier compared to the corresponding alkenes. So this means that alkenes, like we have same carbon number. Ethene will burn more sootier compared to ethane. Okay, why? Okay, the reason is the percentage by mass of carbon in the alkene is higher than in the alkane. So let's see the table. There are two hydrocarbon. One is hexane, one is hexene. So you need, just now you have know that the percentage of carbon contained in alkene is higher than alkane. So how do you determine this? So you need to find the relative molecular mass for both hexane and hexene first. Then you calculate the percentage mass of carbon. So just take the molar mass of the carbon atom. So there are six carbon atoms, so 6 times 12 over 86, which is the relative molecular mass. And you will obtain 83.7% for hexane. And for hexene, you get 72 over 84 times 100%, and you will get 85.71%, which is higher the percentage mass of carbon than the hexene. So the conclusion is, as the percentage of mass of carbon is higher in hexene, it will burn with more sootier flame. Okay. Just now we have completed the part for combustion of alkenes in excess oxygen. How about the combustion of alkenes where the oxygen is limited, is inadequate? Okay, so if the supply of oxygen or air is limited, incomplete combustion of alkenes will occur. So there will be minor changes in the final product. Okay, note that the final product is either carbon monoxide or carbon and water. So these two equations are the incomplete combustion of ethene. So the first equation is the final product is carbon monoxide, and the second equation is carbon. Okay, this carbon will appear in black soot. There is an exercise for you all to work out. Okay, write the equations for the complete and incomplete combustion of butene. Okay, I will upload the answer for you to check later. So we'll move to an interesting part, which is the addition reaction of alkenes. Okay, alkenes contain a double bond between carbon atoms which is unstable. This causes the alkene to be very reactive, and it undergoes addition reaction in which the carbon-carbon double bond breaks open to form two new single bonds. So when an alkene undergoes addition reaction, the unsaturated hydrocarbon itself is converted to a saturated compound. So there are 5: addition of hydrogen, halogens, hydrogen halides, water, and hydroxyl group. Okay. So we'll look at the first addition reaction of alkenes, which is the addition of hydrogen. A mixture of hydrogen and the alkene gas is pass through the catalyst at a specific temperature to produce an alkane. Okay, this is a special part. If you see the example, ethene, you mix with the hydrogen gas, okay, and you use either platinum or nickel at 180 degrees Celsius, then the final product is ethane. Okay, why we will have the catalyst in this reaction? Okay, remember the function of catalyst is to optimize the chemical reaction. Then you get more final product. Okay, so either you choose one catalyst when you write in the chemical equation, which is platinum or nickel. So the addition of hydrogen in alkenes, we also call this reaction as catalytic hydrogenation. Why catalytic? Because you have the use of the catalyst. Okay. So this is a structural chemical equation. Okay, you will see that the carbon-carbon double bond will break, and the two hydrogen atoms will be added to the ethene. So you will get ethane. So either you leave your chemical equation in the word form or the structural form, but you also need to know that you have to write the catalyst and the temperature at the arrow sign here. So for further use of hydrogenation is to make margarine from vegetable oils. The second addition reaction, which is the addition of halogens, or we call as halogenation. Okay, the halogen, chlorine, bromine, and iodine reacts with the alkenes, and there's no catalyst of ultraviolet rays is needed. So an alkene react with the halogens in the condition the presence of bromine water or tetrachloromethyl. Why? Because this bromine water will only activate the chlorine gas or the halogen you use. So let's say if you use bromine water, the reddish brown color of bromine is decolorized immediately. So the colorless liquid is formed. Okay, this colorless liquid is your final product. So look at the example. Ethene, you react with chlorine gas. Okay, the final product is 1,2-dichloroethane. 1,2 because there are two carbons and there are two Cl substitute at the first carbon and the second carbon. So this is the IUPAC nomenclature. And this process can be also called as chlorination. So the third addition reaction is the addition of hydrogen halides. So alkene, you react with hydrogen halides. You can have HCl, HBr, or Hi. Okay, at room temperature without catalyst. So the product form are halogenoalkenes. Okay, so let's say the ethene, this double bond will break, and then the hydrogen atom will link to one carbon, and the Cl will link to another carbon. So you will have this structure, and this structure will name as chloroethane. Okay, this is the chemical equation. C2H4 plus HCl, you get C2H5Cl. Okay, so the fourth reaction is the addition of water. So we can call it as hydration. So the mixture of alkene, you mix it with water in the form of steam, pass through these three conditions. Okay, these three are important. You need to memorize them. Okay, catalyst is the concentrated phosphoric acid. On the temperature is at 300 degrees Celsius and the pressure is 60 atm. Actually, the addition of water is also the preparation of alcohol. So the final product will be alcohol. Look at this example. Okay, the ethene, okay, the double bond will break and one hydrogen atom will connect to this carbon and the rest is the hydroxyl group will connected to the second carbon atom. So it will form all single bonds. So the final product is alcohol, right? So ethene, okay, you react with water, then you obtain ethanol. Okay, Okay, for alcohol, it ends with OOL, ethanol. Okay, this is a chemical equation, C2H4 plus H2O, you will get C2H5OH. Or you can write it as C2H6O. It's also acceptable. The final addition reaction is the addition of hydroxyl group. So the reaction is between the alkene and the acidified potassium manganate 7 solution. Okay, so alkene has a property to decolorize the purple color. Remember the colors in chemistry, they are important. Okay, the alkene decolorized the purple color of acidified potassium manganate 7 solution after added to it. So this is because in the addition process, there are two hydroxyl group added to the double bond. So when the double bond breaks, right, like this double bond breaks, and you get one OH group from the water here and another one to here. Okay, so the final product is colorless and we call it as diol. Why diol? Remember the fact is they have two hydroxyl group. Okay, this is also a test to distinguish between alkanes and alkenes. Why? Okay, if you want to differentiate which one is alkane, which one is alkene, just add alkane to the potassium permanganate solution. Okay, there will no changes of colors. It will still remain purple. If you pour alkene to it, it will change it from purple to colorless. Then you can conclude that this one is alkene. Okay, so and you need to be careful when you write the chemical equation because you need to have this part. This one is the oxidizing reagent of which is the acidified potassium manganate which produce many O2. So you only have another OH group after in the water. Okay, the very last part, which is the polymerization of alkenes. What is polymerization actually? Okay, polymerization is the process in which small molecules, okay, or the basic unit lah, okay, we call monomers are linked with one another to form a large molecule of long chain, which is called polymers. So if you use alkenes as monomers, this polymerization, we will call it more specific, is the addition polymerization. Okay, in this example, we use ethene. Ethene then undergoes addition polymerization, and the final product we form and we name it as polyethene. Okay, if you use other alkenes, just and you worried about how is the naming of the final product. If you use other alkene, it's very easy. Just add the poly in front of the monomer. Okay, in this case we use ethene. So just add the poly in front, and the final name will become polyethene. Okay, this is the structural chemical equation. Okay, take note. This is a special way to represent the chemical equation. Okay, look at this N. This N is very important. If you lose it, it doesn't carries out the meaning of polymerization. Why? Because N means it stands for the repeating unit. Because just now the definition said the polymer will be in a very long chain. So there's repeating units. So will be more and more. You can be hundred or thousands or even more than this number. So the double bond will broken and you will change it to a bracket, which means that it is very long, and the end here also represents the repeating unit. So you need to also know the uses, okay, uses of the polymer. So it also can be asked in the exam. Here are other examples. We have propene, vinyl chloride, tetrafluorine, and just now I have already mentioned the polymer name. Just add the poly in front. Okay, you see? Then the users you also need to know them. Okay, thank you for watching my slide and I hope it helps you. Thank you.